All right, let's see what I got to start with. Okay, we already talked about your learning goals. The course outline for science, environmental science, again, is on your inbox. So when you go into that course, you should see a copy of it. And you know, already know, I talked to a few people already how to access to make sure you can get into it. So today we're going to look at basically when you first do the science middle school, I know you've got some idea what science is all about and how we study science. So we're just going to look at some of the methods that they use very briefly today. But the important thing I want to talk about is energy. And energy is important to science in general, but specifically to environmental studies. Okay. So we're going to look at some questions later when the assignment's going to be on key concepts of energy. Now, what's a key concept? Whenever you're reading an article or a journal, or even in English, you're looking for what are the important points. If someone were to ask you, you read this page and say, what is it all about? So you could write in point form, what are the key concepts? What's the story all about in 3 or 4 or 5 points? That's what key concepts are. So in science, basically, all of your preamble to the course is the same that we had for math, so I'm not going to go through that. I just want to look at the general topics. We're going to start, like in both environmental science and science. In science, it's going to be, there's an environmental unit, so it's an introduction to environmental studies. We spend a lot of time on that. I'll try and touch a bit on throughout the year. It's a full year course for science, both semesters in grade 10. So you're going to have a bit of chemistry, physics, and maybe part of the weather unit. Because it's a year-long course, your mark's going to be divided 50-50 between what happens between now and January to June. So if you come pretty good between now and Christmas time, and then you don't come at all or very little after, you won't be able to get your credit for science. And like I said before, the assignments are worth 40, your tennis participation is 20. If you do at least that, you're going to get a pass mark. If you don't, then you're not going to get your science. You're going to need that credit. And for grade 12, you need the at least a science credit in grade 12 to get your, or grade 11 and 12 to get your diploma. So environmental science is a good choice. Physical geography, you can either use it for your science credit or for your humanities. And again, the introduction to environmental is the same. The preamble about what you need and how your marks are worked out. But here you can see that we're going to be looking at concerns and issues in environmental studies. To begin with, we'll talk about ecosystems, renewable resources, and protecting our planet. So issues that are very important to everybody today. So, first question is, let's go big. Not just talk about what's in Bathurst, but what are the 10 things that make up the universe? So what can you give me as an idea? That could be anything, maybe from the Earth. What are things that make up the things around us? Very simple, basic things. Someone give me one thing. All right. What else is in the universe? Atoms. So you see atoms when you look up in the sky? What would you see when you look up in the sky? Stars. Stars make up part of our universe. Does anybody know what stars are made of? So real specifically, what are those things? They're not made out of planets, but planets is another thing in university. There's stars and there's planets, right? What's the difference between a planet and a star? One's on fire because it's burning what? Gas. So that's what stars are made out of. Yeah, I'm just trying to get this thing over here. So stars are made of gas, and planets
pretty solid, right? What do we got on our planet?
Rocks, okay.
Soil, rocks. What else is there?
Water.
What else is there? What do we breathe? Air, oxygen. We also have other things in the air. There's oxygen, there's carbon dioxide, nitrogen. All of these things are in the air, but we only need the oxygen.
So some of the common things we see are stars and planets. But on our own planet, we have soil, water, air.
You said people. Are we the only living things on our planet?
There's animals.
Insects, right? Bugs. What else grows on our planet? Plants. Plants, not just planets for beings, but plants. Okay, we got almost 10 here. Textiles, it's manufactured.
Reptiles. Reptiles.
They're an animal, right? They're a type of animal.
That's right. But now if we look at trying to group
These things, make two big groups. Can you see things that can be one or the other?
well, you mentioned atoms.
Atoms make up things that we call matter, right? Things that have substance or size to it.
All these things that we can see
See on Earth, what is the things that we use but we don't see? When you look up here, what the heck is
light, right?
What else do we have that helps us function in the world?
Electricity.
You can't see it. You can see the results of it, right? You're looking at static electricity on a ball. Yes, you can make it, but all you're seeing is the results of the light that electricity would generate. But electricity itself, you can't see it. You can see the results of light waves.
What about things we hear?
What do we call that? Hey, excuse me, mister. I'm asking you third time and last time. If your head's down, I'm assuming you're on your phone. So can you just look at here then? Or do you want to be in this course? I mean, you don't have to. You don't want to be here. Okay. But I'm not forcing you to be here. If you don't want to be here, you could go up there. It doesn't hurt me. Just I'm trying to get you to at least learn a little bit. Okay?
Now, these things here are not what we call these things. Okay? We can put things like
maybe stars as a type of matter because it's made out of gas, but it's still made up of atoms. It's still matter.
So if we were to group all of these things into two groups, what do you think we could call it? Well, planets and soil
And water and air and gas,
they're all
matter. And things like sound and light, nuclear, electrical, mechanical,
are all types of
energy. These are the two things that make up the whole universe, the two types of things. Okay? So if we had to group them into the smallest bunches, we would use this. Some things we can see, some things we can't in matter. And scientists lately have actually said there's two types of matter. There's dark matter. Dark matter and matter that we see, like light matter.
and then there is also dark energy, which is something I'll talk about later. Now, I don't expect you to be
Studying this, I just want to give you a general idea that what we are here is nothing. You know, we always think that in our society we're very, very important. But think about it. We're one planet in a solar system that has 9 of them revolving around the sun. Our own solar system is a small little dot in the Milky Way, a galaxy that has 100 billion planets. 100 billion planets in one galaxy. And that is just a small part of the universe.
So we can call things as normal matter, like this. The water we drink, the food we eat. 5% of what's in the universe is normal matter. It consists of atoms, makes up stars, planets, human beings, and every other thing we can see, visible thing we can see. There are 4 types of matter. We already talked. Anybody give me one right now? What do we call this type of matter? Wood or rocks, it is solid, right? And if it flows, it could be gas, and liquid is the third one. And the fourth one you may not have heard of, but it's one called plasma. When you ionize gases in space, it creates a new substance called plasma. Now, the most important part of matter is called dark matter. Now, they haven't been able to prove it, but they theorize it. They use this name WIMP. Okay? It is massive particles, widely interspaced massive particles. They're so small you can hardly see them. In fact, we can't see them because they're invisible, but they're heavier than any other objects around them. They have lots of density to it. So dark matter is like the wind. We can't see it, but we know it's there because we feel it. It's strong enough to hold everything together, because all that stuff we call in space, what's holding it together? It's not just empty space. There's actually dark matter in there. It actually has gravitational attraction. And it's very cold, and it's slow moving, unlike some gases which are fast moving. There is dark matter, but there is still a lot of void. But there's the matter that's in space is so small, only 5%. And if we look at the energy that it produces, which is a lot more, the energy is actually 70% of the universe. So what is there more of in the world, in the universe? There's more energy than there is matter. More energy. We are energy. Our body, as you probably learned in biology, is like 70% water. The rest is all this other substance, the skin and the bones and stuff. However, what makes us function? Well, when we eat, that food is metabolized through chemical reaction to go to our muscles so that we have mechanical energy. But our whole body works with the most important energy, electrical. Our brain, our body is all electrical. Without electrical energy, there wouldn't be any life. So dark energy is the one that we have most of. And the reason why I want to show you this slide is because I want you to appreciate how important energy is in the world, in the universe, and how important it is to life itself, our life right here. And why do we know there's dark energy? Well, one time, if you've seen the show The Big Bang Theory on TV, Sheldon Cooper and all that. That's a comedy. Well, they talk about how the world started. It was a very small particle that exploded 14 billion years ago, and it started expanding. And up until 1990, they believed that was all it did. But they proved just recently that it's not only expanding, but it's accelerating. It's going faster. And because it's accelerating, the only thing that can do it is what they call dark energy. So this is what it would look like. Those blue dots are what would be like the Milky Way, what we are a part of, that tiny little speck in the Milky Way. That is a galaxy made up of billions of planets and stars. All of that red stuff there is dark matter. So that is 25% the light matter's 5, and the rest of that stuff is dark energy. So that gives you an appreciation about how relative matter and energy is. Now, what's science? What do we do? And you learned this back in probably, it may be when you start doing science, was it grade 6 maybe, or maybe 4? All right. So science basically is we're trying to get a better understanding about how things work around us. Try to explain why things happen the way they do. And of course, this is how scientists do it. They have to make an observation. They have to see what's happening. They collect that data, and then they sit down and say, well, what does it mean? They organize it, and they try to interpret it. And they come up with an idea and say, well, this is why. They make an hypothesis. And they try and solve this problem. Sometimes they do, sometimes they don't. But the last thing is very important. This is why we have to learn to read, because we have to communicate that. Most scientists write it down. It's either in books now, or you can go onto the internet. It's written, and now they use a lot of videos to explain things, because people learn a lot too by watching videos and listening. So they need to communicate that. It's no use if Albert Einstein, when he developed his theory of relativity, if he only kept it to himself, we wouldn't know, how the universe really was. We'd still be thinking like Newton did. The apple fell on his head. There's a short little video here. I'm just going to put it on. I'm going to put this on pause. All right, so that gives you just a basic idea of what science is. Now, energy, we're going to jump right into it. So like I said, everything in the world is either energy or matter. But the most important thing is energy. And as far as we know, there's only 2 types of energy that we get. Energy from the sun. The sun makes everything grow, keeps us warm. If the sun wasn't there, we'd die. We wouldn't have anything to eat, we'd freeze to death. The only other place we get energy is from the actual center of the earth. It has a radioactive core. It is emitting radioactive heat. Okay? The core is molten, so the decay of these elements inside the earth also provides some energy. If you put water way down into the earth, seeps down there, it gets warm. People actually drill holes now, 200 feet or so down, and they pump that water back up. That heats their house. Geothermal energy. You've seen pictures of Old Faithful geyser, one that's up in the air in the American Park. Those are hot geysers. So people in Canada, a friend of mine in Newfoundland, he doesn't use electricity to heat his house that he gets from, like from your coal burning stations. He actually has a drill down into the ground, and the water pumps up is hot. That was what generates the heat for his house and makes electricity for him. So, for most of us, it's the sun that gives us the most of the life, most of the energy, and electromagnetic waves is how it comes. We don't see it. It's a wave. Now, you get too much of it, it can be bad. You get sunburns. That's ultraviolet rays. If we were to not have any protection from the ultraviolet rays that come from the sun, we'd all die of cancer. But there's something up there that protects us. What is it called? Around the Earth, inside our atmosphere, there's an ozone layer. And I'll be talking more about that later. That's what protects us. That's what stops some of that UV radiation from coming from the sun and killing our cells. That's what cancer does. Energy goes through our system. We know that how do we live? Well, we eat something. We transfer that energy from one living thing, from a plant or an animal, goes into our body. What happens when we die? We go into the ground. If you're buried, some people get cremated. But if you're put into the ground, you become food for the insects, the bugs. So it's a big circular system. It's eat or be eaten. So forms of energy, another short little bit. All right, so I'm giving you an article to read for an assignment. The print is very small, but if you can enlarge it on your computer, you can make it bigger. I have printed out a copy that you can take with you. If you can read it in the hard copy, fine, but if you're having trouble reading it because it's very small, like that, then
Use the computer to enlarge it, okay?
I just tried to put it all in. That's the way it came. So what I want you to do is write a list of key concepts of energy from that. So from that article, I want you to pick out some key points, things in a bullet form, okay? And remember that when you hand it in, because we're trying to get it into organized, you're going to put the title. Since it's Science 10 and it's also environmental science, it's going to be your assignment number 1, okay? And the title of it is Key Concepts of Energy. So you can put today's date on it because you start it. Make sure you put your name. That's what I mean. It looks like this, but you can go to view. And actually, I can zoom this in if I wanted to. Oops. And go even higher. So whatever you want. Yeah.
So play around with it so it's good for your eyes.
I'll give each of you a copy of that. All right. So any questions so far? What I want you to do, I want you to read the article and look for key concepts. So it means you got to pick out the things that are important about energy in that article. All right? All right, I'm going to shut this off.